Welcome again to Advanced Function MHF4U1. Today we're going to explore learning about operations with functions. So today's learning goal is to use different operations of a given functions. So first we need to understand the arithmetic combination. So what that means is that we're given two types of function f at x and g of x. When you're given two different types of functions, the first operation, if you were to add the function in terms of the input is x, then you can separate it as f at x plus g plus x. The second operation is if I were to combine by subtracting in terms of the input x, then you can separate it with f at x minus g of x. The third, if I were to multiply together f times g together with the input of x, then you can separate it with f at x times g at x. And lastly, you can divide it by f over g of x, and you could separate it with f at x divided by g of x. Now keep in mind for the last part, the denominator, we have to restrict it so that it does not equal to 0, or else it will be undefined. So let's try some question. Given f at x and g of x. So first, I want you to first find the combination of f plus g when the input is 1. So first, f plus g, input is 1. So that means that I will be adding together. So you could say f of 1 plus g of 1. So I'm going to put them together, f at x plus g of x, and then let's plug it in. I'm plugging in 1, so 1 squared minus 1, 1 minus 1. So this is 0 plus 2 times 0, so the answer is 0. So the combination of f plus g in terms of x is 0. Okay, now let's try the second one. B. So f times g, so we're combining in terms of x, is equal to f at x times g of x. So therefore, we're going to multiply f at x is x squared minus 1 times 2x minus 1. So here we're going to do a distributive property. So 2x squared square root x minus 1 minus 2x minus 1. So unfortunately there are no like terms. So therefore the final answer for this will be this. Okay. Now, they may ask you, what about the domain of a combined function? So the domain, if you were to add, subtract, or multiply a function, the domain of the function, this means intersects. Okay, so intersects with the domain of g function. And also, another unique thing is that if I were to divide up the combination of the function, then we do know that the domain will be when they intersect, but the restriction is that we have to make sure that the denominator does not equal to 0. Okay, so whenever you're combining a function, try to combine and simplify as much as you can, And when they overlap the two same domain, that will be the domain of the function. So let's try this. So find the domain of f plus g of x. So therefore, this is going to be f of x plus g of x. So x squared minus 1 plus square root x minus 2. So unfortunately for this one, there are no like terms. So what I'm going to do is I'm going to draw these two graphs separately. So f at x, it has a vertex at -1, and it's a parabola that opens up. So it does intersect at 1 and -1. We have g of x, which is x minus 2, square root. So my starting point is at 2, and it's going like this, the square root function. So you will notice that these two graphs will intersect, okay? So when it's at 2, it's going to be at 3. So to find the domain, you have to find the two graphs when the domain x overlaps. So as you can see, the two graphs will start to overlap at 2. So at 2, over here, these two graphs are going to overlap. The domain of the given graph is, for this one, is x can be any real number such that x must be greater than or equal to 2. So it's important to note that if you could simplify algebraically as much as you can and then draw it, that's your domain. But if you have unlike terms, then I would recommend you to graph it and see where the two graphs overlap in terms of x value of domain.